J.I. Case Company and your local case dealer presents Understanding Your Case Baler. The purpose of this presentation is to give you, the producer, a blueprint for making top, I repeat, top quality hay, to enable you to put up bales like this one that contain all the leaves of the original crop, high protein hay that will yield a greater return of milk or beef. To get this quality, farmers agree on 3 basic steps. Step 1. The ideal time to harvest is at the first sign of bloom, to the stage where 1/10 of the crop is in bloom. In addition to capturing maximum food value, total digestive nutrient, there is less damage and loss because the hay is more pliable at this stage. The second step is windrowing and conditioning in one operation. The standing hay is cleanly cut and formed into a fluffy windrow without ever touching the ground. Case offers 2 pull type and 4 self-propelled models with header sizes ranging from 8 feet to 16 feet. The final step in the harvesting of top quality hay is a leaf-saving baling operation. What does Case have to offer to do this vital job better? First, meet the popular price model 230 baler. While relatively light in weight to provide greater flotation and maneuverability, the 230 is exceptionally rugged because of the amazing simplicity of design. The key to its leaf-saving ability is a Case exclusive, the sweep feed arm, introduced by Case in 1960. Now, for higher density baling, let's look at the Case Deluxe Model 330 baler in both twine and wire tie. This is our heavyweight custom-designed baler. It turns out twine bales up to 85 pounds or 100-pound wire-tied bales in the popular 14-inch by 18-inch size. Let's take a walk around one of these high-capacity balers to find out what makes them the leaf-savingest balers around. Note the extra-long heavy-duty drawbar with adjustable hitch on this 330. The snug-fitting clevis insert is especially hardened for long wear. The PTO yoke stand is easily and quickly adjusted to provide a straight-line drive for smooth, vibration-free power transmission behind any tractor. The yoke stand, which holds the PTO, is reinforced to afford more rigid support when turning corners and to furnish correct alignment with the tractor. Changing from transport to field position is easily controlled from the tractor seat on both the 230 and the 330 balers by just giving a tug on the latch control rope. Heavy slugs are ironed out by this inertia-building flywheel, which weighs in at 200 pounds on the 230 baler and 260 pounds on the 330. Inside the malleable gear case is a set of hypoid gears which run longer and quieter than ordinary bevel gears. Double protection is built in at the flywheel by a slip clutch and shear bolt. The slip clutch function is to cushion the plunger stroke. A quick check for proper adjustment can be made by simply feeling the shield to see if it's running warm. Excessive shear bolt breakage indicates improper adjustment. The clutch facings are frozen together or the spring tension is too weak. The 330 baler uses a grade 8 shear bolt. A grade 5 bolt is recommended for the 230 baler. The 230 and 330 safety features include 1. A slip clutch and plunger shear bolt. 2. A spring-loaded sweep arm. 3. A pickup overrunning clutch and shear bolt. 4. A knotter arm shear bolt plus needle safety latch. 5. An auger assist shear bolt on the 330 baler. Here we see the 60-inch wide pickup with the flare which enables the baler to pick up extremely wide windrows. Notice the exclusive Case leaf-saving strippers with the turned-up lips which prevent leaves from falling through the teeth openings. Here's a tip to save wear and tear on the pickup teeth. Adjust the pickup so the teeth will clear the ground by at least 1 or 2 inches. The wind guard has a spring-loaded knee action which puts a uniform pressure on the windrow to assure uniform feeding of the hay into the bale chamber. The wind guard on the 330 works 2 ways. If you're driving so the hay comes in one side of the pickup, the wind guard will lift up on that corner only. It also tips fore and aft, maintaining the right tension on the hay as it's fed into the pickup. On the 230 and 330 balers, the tooth cam track has been designed to furnish a smoother lifting action to bring the hay into the pickup with less leaf loss. This provides a more rugged, more adaptable pickup. As you see here, the 2 outside pickup fingers are at a delayed action. The reason is that it allows the sweep arm to uniformly feed all of the hay into the bale chamber instead of bunching or slugs. It gives the hay a slowing action to feed smoothly into the bale chamber. We see here a simple adjustment on the floating pickup. Adjusting the tension spring at top left gives the pickup the proper floating action. The optional gauge wheel is available as needed. This is the sweep arm head and fingers, important in the feeding pattern and the making of a bale. When changing your type of baling, say from alfalfa to milo stalks, the setting on the feeder head must be changed. There are optional superfeed fingers available to assist in feeding short or slick crops. The 3 front fingers are 3/4 inch wide at the top and tapered onto a point. Because they are 1 1/4 inches longer than standard feed fingers, you should adjust your pickup accordingly. The 330 baler has an auger assist shown here in the upper left-hand corner of the pickup. The auger enables the feeder arm to handle a larger quantity of hay. This auger assist in the 330 baler now has a 1/4 inch shear bolt that provides protection in case of an overload or obstruction. This picture is typical of a competitive baler with extra moving parts and a generally over-complicated feeding system. The hay is fed at a right angle rather than the smooth curve as in the case baler. This right angle movement of the hay increases leaf loss and bunching. The difference between a case baler and a competitor's is immediately obvious. As the case sweep arm feeds, it continuously folds the hay as one would fold a towel. This folding action captures the precious stems and leaves inside each slice. Competitive balers, feeding on a 90-degree angle, tend to tear the hay apart and drive it into the bale case in such a manner that it produces leafless stalks and bales that are sliced open on both sides of the bale. When cattle feed on this kind of bale, they sort it out and do not eat all of the hay. Each manufacturer claims his method of handling hay is the most gentle. Let's understand here and now that the case sweep feed surpasses any other system in the gentle handling of hay. The sweep arm moves hay from the pickup, not just up to but all the way into the bale chamber in one continuous motion. It begins with a sweep arm in the out position as shown here and moves the hay all the way into the chamber in one gentle sweeping motion. There are no abrupt corners in which the hay can be pushed, pulled, or forked around. The free-floating fingers of the sweep head automatically fold back to pass over the hay on the return stroke. They then reset to grasp the hay on the feed stroke. The sweep head can be positioned forward or to the rear of the sweep arm to vary the distance as it enters the bale case with a charge of hay. The sweep feed drive is a simple but beautifully designed method of utilizing the power of the back thrust of the bale plunger to feed the hay into the open chamber, which makes it impossible for the sweep arm and the plunger to get out of time. As the sweep arm is feeding, the plunger is returning. While the plunger is compressing, the sweep arm is retracting. This counterbalanced action eliminates the surging action common in other balers. The entrance of Case's bale chamber is unusually wide for big capacity reception of windrows. The spring-loaded sweep arm acts as a safety factor if a foreign object is fed into the chamber. The correct setting of the springs is important to get a smooth, cushioned action from the sweep arm. The 230 baler has a 14 by 18-inch chamber with 3 hay dogs on top and 2 on the bottom to hold the hay for proper tying of the bale. The hay groovers on the top of the bale case also assist in holding the hay back and keep the needle slots clear of trash. This eliminates trash interference with the needles. The plunger runs on 4 roller bearings. There are also 2 front rail guides on the right side, and the knife runs in a lowered track for smooth, positive alignment. The 230 plunger has a 26-inch stroke at 65 strokes per minute with a high-carbon steel knife which is tapered to shear the hay with a scissor-like action. This contributes to a lower power requirement to operate the baler as well as cleaner cutting. The 330 baler also has a 14 by 18-inch bale chamber with the plunger running on 5 roller bearings and the rail guides on the right side. The rail guides are notched to be self-cleaning, thereby assuring a smooth-running plunger. The 330 bale case has 4 hay dogs on the top and 1 on the bottom of the chamber, plus the hay groovers to help hold the hay back and keep the needle slots open. The plunger face of the 330 is reinforced with heavy gussets and forming angles to ensure a densely packed bale. The 330 plunger has a 28-inch stroke at 65 strokes per minute. The rail underneath the shear bar is conveniently adjusted by 2 draw bolts. This assures that the knife and shear bar are properly aligned to afford a clean cutting action of the knife at all times. We now come to the heart, the essence of the case baler. The case knotter is an outstanding example of simplicity and trouble-free performance, the result of painstaking research and testing to develop an ultimate performance bale after bale, year after year. Only 5 major points on the knotter are evidence of case design simplicity. You don't have to be an expert to set it. One of the things that make a case knotter superior to any other knotter is its patented offset bill hook. On the right is the case bill hook, a competitive bill hook on the left. Notice the case bill hook is offset, an exclusive case feature. It is made of stellite, one of the toughest, hardest materials available. Competitive bill hooks are made of castings that are plated with either chrome or cadmium, which can wear off and permit rust to form. Let's consider the simple process of tying a box with a tight string. You usually need help to keep a tight string and tie the knot. If you tie the knot on a box with a loose string, however, it would be real easy to do, just like the case offset bill hook does it. It gives you slack twine to tie the knot with ease. The case offset patented bill hook produces a wider arc. In other words, it picks up the slack twine and ties a tighter bale with less chance of error. Competition uses a smaller arc with a straight bill hook and has to pull the twine throughout most of the 360-degree cycle. This illustration shows how the case bill hook, left, pulls the twine from the bale. We only pull a nominal amount of twine from the twine disc, whereas competition has to pull 1.5 inches of twine from the disc with their straight bill hook. The case knotter also features an exclusive 5-notched twine disc. Most competition, because they have only a 4-notch twine disc, has to move the twine disc faster between notches, which increases the possibility of more missed knots. With the 5-notch twine disc, the twine is positioned directly over the center of the billhook. With a 4-notch disc, it is necessary to put a guide on the knife arm to position the twine over the center of the billhook. This in time will create problems due to wear in the guide on the knife arm. How a knot is tied. The sequence of a billhook tying a knot takes about 1/8 of a second. 1/8 of a second. Twines lying over the billhook. 2. On the first quarter turn, the offset billhook is picking up twine from the bale and the twine disc. 3. At half turn, the tongue begins to open on the billhook. 4. At 3/4 turn, the tongue is open and the two twines move between the tongue and the lower lip of the billhook. 5. The billhook tongue clamps down on the twine, and all that has to be done is to tighten the knot. 6. Knot is wiped off the billhook by the stripper pad. When the bale reaches the proper length, the measuring wheel trips the tying mechanism, and the needle brings the second strand of twine through the guide of the knife arm across the billhook into the twine disc. The disc pinion has turned the twine disc sufficiently to permit the twine holder to steer both strands of twine into the disc. At this stage, the billhook is starting its revolution. Note, the offset billhook is starting to pick up the twine from the bale. Here, the needle is dropping back to put it into the twine disc, and the billhook is at half-turn position. The roller is engaging the cam on the knotter casting, opening the tongue on the billhook. The billhook has turned, forming a loop of the twine around the hook, and the jaw has opened to receive the twine. The knife is advancing, ready to cut the twine between the billhook and the disc. At this stage, the needle continues to recede, leaving the twine in the disc where it will be held for the next knot. The billhook jaw has closed and is holding the ends of the twine tightly. The twine has been cut, and the replaceable stripper pad on the knife arm is advancing to wipe the loop twine from the outside of the billhook as the jaws firmly hold the two cut ends of the twine. The knot is tied and is already dropped from the billhook, completing the tie around the bale. The needles return to the home position, leaving the strand of twine in the disc and extending through the bale chamber, ready to receive material for the next bale. This shows the knotter lifted, revealing the proper adjustment of the twine dump finger, which should be directly parallel to the bale case needle slot. If the wrong adjustment is made, you could have serious tying problems. The purpose of a twine dump finger on the 330 is to hold the twine so the billhook can pick it up and easily make the knot under the most adverse conditions. Now the twine dump finger is moving underneath the needle. This twine dump finger should be adjusted within 1/16 of an inch of the needle so the twine cannot get behind it. Caution, if you break a needle, be sure you go back and readjust the twine dump finger. We have to be sure the knotters are set right, or they can present a few problems like these. Knot in twine over bale. The tucker fingers did not pick up twine or move it into the tying position properly. You'd better readjust the tucker fingers and also check the twine tension. Possibly the hay dogs are not entering the bale case. The way to check this is to clean around the hay dogs and examine for broken and unhooked springs. Twine broken in knot. Extreme tension on billhook during the tying cycle causes the twine to shear or pull apart because of the crochet hook or rough edge on the billhook. There's also a possibility of sharp edges on the stripper pads. Well, you'd better loosen the tension on the billhook and try smoothing off all rough edges and surfaces on the billhook. Here's a knot that's too loose because there's not enough tension on the billhook spring. Now this is easy. Just add more pressure on the billhook. Look at these frayed twine ends. You most likely have a dull twine knife. Let's sharpen her up. On a new baler, there may be too much paint on the cutting edge of the knife. Get it off. These uneven twine ends could be caused by insufficient twine tension on the twine disc holder. If so, better tighten her up. Good idea to also see if the knife is dull or chipped. Might need sharpening. Look at this. No knot in either twine. The twine has likely sheared in the twine discs. Just loosen the twine holder and/or remove all sharp edges and burrs on the holder and discs. It's also possible the billhook is not revolving or the tongue fails to open. You then better check for a lost or sheared pin in the billhook pinion. Also check for lost or worn billhook tongue roller and cam. Here's a knot in the needle twine. The twine over the bale has pulled out of the twine disc. This can be detected by the square cut end which has been flattened in the discs. This twine will usually be shorter than mating twine tied on the opposite side of the bale. Correct this by increasing tension on the twine holder disc spring and/or decreasing tension with the bale tension cranks. On the other hand, the twine may be sheared rather than pulled out of the twine discs. Check for frayed or torn twine end. To cure this, decrease tension on the twine holder disc spring and/or decrease tension with bale tension cranks. If a strand of one twine is doubled back through the knot, the billhook is pulling more twine from the disc than is needed to tie the knot. We suggest you tighten the twine holder a quarter of a turn at a time until both ends are even. This double bow knot is caused by insufficient travel of the knife arm pad past the billhook, or it may be the billhook pressure spring is too loose. Replace the knife arm or knotter cam. Better think about tightening the adjusting nut on the billhook pressure arm spring. If there's a single twine bow knot, the billhook pressure arm spring is too loose. You can tighten the leaf springs on the twine holder or tighten the adjusting nut on the billhook pressure arm spring. Should the twine be cut and/or frayed behind the knot, it is caused by sharp edges on the stripper arm. The cut in the twine will be 1/2 inch back of the knot. If the cut is 1.5 inch behind the knot, the source of trouble could be the stripper pad bolt head and star washer. If the cut is 3 inches behind the knot, check the knife bolt head and washer. If the cut in the twine is from 3/4 inch to 1.25 inch behind the knot, check for a rough knife arm. It would be an A1 idea in all these cases to make certain that the stripper pad on the knife arm contacts the back face of the billhook. Smooth off any rough edges in the twine notch of the knife arm. Suppose the needle twine is over the billhook tongue roller as shown in our illustration, or the second knot tied on the billhook. This needle twine did not enter the twine disc. Your problem could be improper twine tension or improper twine threading. You could adjust needles and twine disc timing. Check for sheared or lost pin in twine disc pinion or in disc worm gear. Better make certain twine coming from the box is going between the twine tension devices in the twine box and adjust the twine tension to provide a slight drag. Make certain the billhook is timed to the twine disc. Should you discover the needle twine going under the billhook tongue during the first quarter of the billhook travel, it could be caused by the tucker finger not carrying the twine back to tying position. This is easily corrected by adjusting the tucker fingers. Make sure they're in the home position. If the knot did not strip off the billhook, There may be excessive billhook tongue tension, or the knife arm stripper pad is not contacting the back face of the billhook. Possibly, the knife arm travel is not sufficient, or the billhook is worn. The prescription here is to loosen the billhook pressure arm spring adjustment nut. Adjust the knife arm so that the stripper pad contacts the back face of the billhook. Replace cam or knife arm. Smooth off all rough edges on the billhook with an emery cloth. For the man desiring to tie a heavier bale or do custom work, we suggest the Case 330 wire tie baler. Case single twist wire twisters have proven their long life and efficiency for many years. The frame is a single casting to guarantee positive positioning, so important to a wire tie. The Case wire twister is operated by a shuttle and wire holder. As the needle brings the wire up into the holder, the shuttle moves over to the right, grasping the wire as the knife cuts it off, putting a just right crimp into the wire to tie a very tight bale, but not crimping it enough to break off the wire and leave hardware in the hay. On the top, the main drive chain runs both of the twisters. The large sprocket turns once, while the other two sprockets turn 5 times to put 5 twists in the wire. This view shows the needles coming up into the wire holder area. The shuttle bar will move the wire holder and knife over to grasp the wire. Then the needles will return to home position. In the next cycle, the holder will move over to the other side. The little pad sticking to right of the holders is to help position the wire down into the holder area. The needle should be adjusted 1/16 of an inch above the holder and 1/16 inch from the side of the twister shaft. The front end of the twister shows the roller which guides the wire. It is adjustable to keep the twister picking up the wire properly. On a Case twister, we run with what is called a slanted twister hook, not a straight 90-degree hook. A slanted twister hook furnishes a smoother twist. In other words, you're not stretching and tearing at the wire. All Case twister hooks are made of stellite, whose wear qualities give it the ability to tie a minimum 100,000 bales. Also notice the rod alongside the twister shaft. Its purpose is to hold the wire to get a tight twist on the bale. The rod should be adjusted within 1/16 inch of the shaft and 1/8 inch above the twister hook to provide the just right tightness on the twist. If the rod is too far away, the twist will be too loose. If it is too close to the shaft, the twist will be too tight. Now we see the rollers in the needles and the guides in front of the needles. These are dust-proof sealed rollers, the finest in the industry. Make sure all of your guides are adjusted right in front of the needles to allow the wire to go through and that the rollers are free at all times. On Case balers, the needles are adjustable on the rear by 2 bolts to give the just right setting in the knotter and wire twister. There is a guard underneath the needles to protect them when going over rough terrain. It is important that the owner purchases the correct twine. If it is uneven, it simply will not tie right. Twine that is 2 or 3 years old should never be used. Always be sure the twine is correctly threaded and that the proper tension is on the twine coming out of the twine box. All Case balers have room for 4 balls of twine, enough to tie 1,000 bales. The farmer is loading the twine box on a 330 baler with plastic twine, which has definite advantages. It is uniform, and you get more bales out of a ball of twine. Make sure the routing of the twine to the needle and on up into the knotter is correct. In Case balers, we use glass insulators to give the twine a smooth flow and contribute to the right tying conditions. It is important that the insulators are directly in front of the needles. On case balers, the star wheel affords exceptionally accurate adjustment of the length of bales, anywhere from 12 to 52 inches in length. Also, the tension shoe at the top and bottom of bale case is opened up so the trash will clean out. It is more flexible than a solid tension shoe to give the proper bale tension pressure for tying. This bale chamber is most important and has unusual strength without excessive weight. The tensile strength of the bale case on the 230 baler is 25,000 pounds per square inch. The 330 bale case is 50,000 pounds per square inch and is made of Columbium-bearing high-tensile steel. If ordinary steel was used, it would have to be twice as thick to provide the same strength. The 330 bale case is 8 inches longer than the 230, affording additional control for higher density baling. The case hydraulic bale tension device shown here is an outstanding case baler feature. It eliminates a lot of tying problems. If the operator slugs the machine and breaks the flywheel shear bolt, pressure goes back to zero, so he can put a shear bolt back and immediately start baling without having to clean the slug out, which would be necessary with ordinary tension springs. This is a marvelous time saver. This bale launcher is another case exclusive. It fits on the 230 baler and the 330 twine balers. If you're short of help and have to do your baling alone, this bale launcher belongs on your farm. It's one-man haymaking at its best. The bale launcher runs only when the bale is being launched, which greatly contributes to the life of the bale launcher and its economical operation. How does the case bale launcher work? As the bale is pushed back through the bale case and moves up the launching ramp, it trips a trigger device, which causes the linkage underneath the bale case to engage the plunger on its return stroke. Then the linkage is pulled and the launching chain launches the bale into the wagon. This rear view of the case bale launcher shows the spring-loaded launcher wagon guide and the heavy-duty drawbar. If you turn a corner, the launcher plays follow the leader with the baler to ensure that every single bale is launched in the wagon. Launch. The bale has tripped the chain. The plunger has picked up the rod to pull the chain at 25 feet a second, and the bale is launched into the wagon. There is an adjustment crank on the front of the baler within the driver's reach to enable him to easily adjust the bale position in the front or rear of the wagon. Up to January 1969, the J.I. Case Company had built 111,817 pickup balers, and that ain't hay. This must account for the outstanding baler we produce today. A baler simple in design, with trouble-free performance and minimum upkeep. They're packed with exclusive features, which makes using them a genuine pleasure and makes money for you. Our entire organization is committed to producing better equipment through research and ever-improving manufacturing techniques, and to place this equipment in your hands with confidence. There's always a cordial welcome awaiting you at your case dealer.